Today is Tuesday, December 1st, and today, students, we're going over lesson number 9, estimating two-digit products. Our learning target for today, I can estimate products of two-digit by two-digit multiplication word problems. Our essential question for this unit remains the same. Why is it important to approach problems using a variety of strategies? We're just going to continue to build upon our answers to this question. So some things to remember regarding the area model that we've been working on so far in this unit. Some important words and vocabulary. Decomposing factors is just like writing numbers in expanded form. So when using the area model, we'll find the area of multiple rectangles by multiplying the dimensions. I've got a question at the bottom here. How can we decompose the factors 42 and 27? So I'm going to pause for a minute and let you, in your notebook, try to figure out the answer to this question. Okay, so when decomposing 42 and 27, for 42, you remember when we decompose, we're trying to break the number apart to a number that's easier to work with. And for 42, that will be 40 plus 2. And for 27, that will be 20 plus 7. So for 42, 40 plus 2, and 27, 20 plus 7. Okay, on our next slide, it's just introducing us to a Jamboard launch activity that has already been assigned to you in Google Classroom by your teacher. And I'll bring that up in just a second to show you which one exactly that we're going to work on first. But over here on the right side, you'll notice there's a little help button. And when you click the help button, it gives you a little short video, an example of how to work the 2x2 area model problem. Okay, just an example of how to work a 2x2 area model problem, just in case you forgot. So this is our first Jamboard that you should have up. Again, this has already been assigned to you by your teacher on Google Classroom. Joshua and Sydney plan to buy rubber tiles that are 1 foot by 1 foot to cover their new backyard play area. About how many tiles should they buy if the play area is 42 feet by 27 feet? How did each person determine their estimate? So again, the key here is going to be estimate. And let's go through and go ahead and do our cubes on this one. And you got a 1 foot by 1 foot area that's going to be covered in the backyard. And you got here key numbers 42, 27, and you actually got a couple questions here that we're gonna underline. So we got how many tiles should they buy if the player is 42 feet by 27 feet, and how did each person determine their estimate? And one of the key words also is going to be the word about. So about is really giving you a clue that you're going to be estimating. Okay. All right. So the first part down here, you got Joshua said they need about 1,260 tiles. Sydney thinks they need about 1,080 tiles. And the salesperson thinks they need about 1,200 tiles. Okay. So we're going to pause for a minute, give you an opportunity to go ahead and reread the problem, reread the questions if you need to, and to go ahead and solve it. So you've had an opportunity to go ahead and work the problem, and here is my answer key, and we're going to take a quick look at it, but we're going to be discussing it further on in just a little bit of time here. Okay, so you got Joshua said that they need 1,260. You take a look at his estimates here, and you got Sydney thinks they need about 1,080. Take a look at Sydney's estimate, and the salesperson. Take a look at the salesperson estimate here. So you got 3 different ones. And we're going to move on to our next slide. Like I said, we're going to discuss this a little bit further here shortly. All right, so some discussion questions for us here. First one, how were each of the factors rounded in the estimates? Joshua rounded for 42 times 30. He rounded the 27 to 30. Sydney rounded the 42 to 40, multiplied 40 times 27. And the salesperson rounded the 42 to 40 and also the 27 to 30. So the salesperson rounded both to the nearest 10. So how can estimating products be used to check the reasonableness of multiplication? Well, if it's relatively close, then you know you're really on the right track. So if your estimate is close to the actual answer, then you know that you're on the right track and it's reasonable. Is it more efficient to overestimate or underestimate in a situation? Well, it depends on the situation, and they both can be efficient. They both can be efficient. So we're going to take our same problem that we just worked on, 42 times 27, just to show when rounding to the nearest 10, which one is actually closer to. The 42 times 27. So for the 42, you see on top I put the 50, which would be if you rounded it up to a next 10, it'll be 5. And going down, it would be 40. So 42 is much closer to 40 than it is to 50. So 42 is much closer to 40 than it is to 50. So you would go 40, 41, 42. So there's only two numbers away. And 42 going to 50 would be 8. And let's look at the 27. So if we went up to the nearest 10, it would be 30. If we went down, it would be 20. So 27, again, is much closer to the 30 than it is to the 20. And that's just one way that you can figure out when you're rounding which nearest 10 is it closest to. And on this slide, it just demonstration shows us the actual dimensions of 42 times 27 would be in the white. So with the white lined outline, that's the actual dimensions if we multiply the 42 times 27. And the estimated one for the salesperson would be the 40 times 30, and this would be the estimated one. And you'll see these are pretty close. These are actually pretty close, and the estimate is reasonable in comparison to the actual answer. So we've already gone over the answer key for that one. So on our next slide, how would you round these dimensions? So you got 84 times 29, 84 times 29. So again, the question is, how would you estimate these? So I'll pause a second, and you can write your estimate in your notebook. So for this one, you've had a chance to look at it. The 84 right here, it's going to be closer to the 80 than it is to the 90, and the 29 right here will be much closer to the 30. So when I estimated it, I would say 80 times 30. And remember, if you multiply the 8 times the 3, that would give you 24. And this is just another shortcut for you to remember when you're multiplying by numbers that have zeros at the end, tens, hundreds, thousands. You multiply the first digits to 8 times the 3, and then how many zeros do you have? That's 1 0 and that's 2 0. You would take that, you would just put the zeros over here. So I would estimate that to be 2,400. So on our next one, how would you round these dimensions? The actual numbers are 49 times 22. So we're going to do the same things, kind of pause a second and give you an opportunity to work that in your notebook. So when estimating this, 49 times 22, the 49 is much closer to the 50, and the 22 right here is much closer to the 20. So we would multiply 50 times 20 as an estimate. And again, if I multiply the 5 times the 2, that gives me 10. How many zeros do I have here? That's 1 0. That's a second 0. Then I just add 2 more zeros. So I would have an estimate of 1,000 for this one. So our next one, how would you round these dimensions? 83 times 98. So in your notebook, go ahead and write it in there. I'll pause for a second, give you a chance to work. Okay, so for this one, the 83 is going to be much closer to 80. And for the 98, it's going to be closer to 100. So I would have 100 times 80. Multiply the 1 times the 8. That gives me 8. How many zeros do I have? There's 1, 2, 3 zeros. 1, 2, 3 zeros. That gives me the estimate of 8,000. So on our next slide, this is just our introduction to our next Jamboard, Estimate Products Jamboard. And this again has been assigned to you in Google Classroom by your teacher. And in a second, I'll be bringing up the exact Jamboard that you should be working on. Okay, so the Jamboard that you should be working on right now, which is also, this is your independent work. This is it right here. The first problem is 28 times 74. So make a note of the actual instructions. Products can be estimated to help determine if it is reasonable. Estimate and then solve each problem. So you're going to estimate it first, and then you're going to solve the problem. So when you solve the problem, it doesn't say specifically what method to use, so you're able to use one of the methods that we have learned about. It could be the area model, the expanded notation, or the algebraic notation. So one of those methods you should be using to solve the problem. 28 times 74 for the first one. Now, keeping in mind that there are 6 total ones up here when you go up to the top. This is problem number 1 of 6. The next one, 84 times 27. The same instructions, estimate and then solve. Number 3, 93 times 57. Same instructions. Number 4, 87 times 54. Same instructions. You're going to estimate and then you're going to solve each problem using one of the 3 methods that we have learned about. 5, 31 times 62, 6, 65 times 39. Okay, so this is going to be your independent work for today, and I will actually give you an idea about the first one in a second. So for the first one, and I'll just go over the first one with you guys. 28 times 74. If you notice, for the 28, I've rounded it up. I've estimated it to be 30 because it's closer to the nearest 10. It's closer to 30 than it is to 20. And for the 74, closer to 70 than it is to 80. And what I just went on and multiplied the 3 times the 7. I got 21, and I counted my zeros. There's 1 0, that's 2 zeros, so I added 2 zeros. So I put my estimate right over here, 2,100. And over here, I decompose the 28. I actually went on and solved the problem. Decompose the 28 to be 20 plus 8, and the 74 to be 70 plus 4. And I went on and did all my multiplications. 4 times 8, 32. And I put my partial products down here. 4 times 20 is 80. 70 times 8, 560. 70 times 20, 1,400. These are all partial products, and my final product, 2,072. So this is 2,072 is really close to 2,100. So my estimate was reasonable. And remember, when you solve these problems, you have to show your partial products, no matter what method that you're using. Always show your partial products. You have to show your steps. Now, for additional practice, there's another Jamboard that's been assigned to you, checking products homework for you to do independently. just to get more practice. And this is the Jamboard here. This is another one, and this one has 3 different problems on it. 57 times 44 is the first one. Estimate and then find the actual solution. So you're estimating over here, and you solve an actual problem on this side. So that's number 1. The second one, 93 times 55. Estimate and you solve the actual solve the problem here using, again, the method of your choice: area model, algebraic notation, or expanded notation. And there's the last one here. And I've already gone ahead and done this one for you. So estimate right here, actual right here. So if you want to use number 3 as a kind of a guide for you, if you run into any trouble with the first 2, just go to the third one and it can help you. Okay. Lastly, for your independent work, you've got 2 Jamboards to complete. And also you've got 15 minutes of Dreambox. So remember, you're working towards getting at least 5 completed lessons done for the whole week.